Tell me, whenever I say inverse, what you think of.
Like the opposite.
Maybe opposite? So if I told you, oh my gosh, whoever just said that, don't say that again. I'm guessing Banks. If I told you that this was, let me change that. This was a relationship, and I told you that this was the inverse of that relationship, what do you notice?
One's times you and one's times.
Okay, so they did what? They just switched, right? Everything became, the operation became opposite. They switched places. So here, these are inverse functions. And it did just switch x and y. Easy enough so far? Let's say I give you this function. And remember, f of x just means it's a function, okay? That's the same thing as saying y equals. It just means function of x, right? Mm-hmm. So we could replace this with y equals 2x plus 5. What does it mean really quick while I'm on that topic? What does it mean to be a function?
There's multiple.
What's the definition of a function? Do we not remember?
It has to have like certain parts.
I don't remember.
A function, by definition, has one and only one output. Output is what in terms of an equation? The what variable?
Equal.
The answer, what does it equal? The y. The y is the output. One and only one output, which is y for each input. Meaning, if I had a graph.
Wait, so anything like f of x or like x of.
If it says f of x, that's telling you it is a function. It's telling you every input only has one specific output that goes with it.
And y.
So if you imagine this graph on a coordinate plane like this, if I went to the point x equals 1, how many corresponding y values does that one have? 2. Do you see that? When x is 1, here or here could be a y value. Okay? That means it's not a function. Not a function. Functions are any relationship that has one and only one output for each input.
Why you got a 1?
That's like a tick mark. Because I'm showing you that the input, which is x, let's say it could be 1 or -1. So it has two different outputs for the same input. So it's not a function. You probably learned, I hope you learned, because we're going to kind of build on it today. I'll come back to this equation. I didn't realize y'all didn't know what a function was. You may remember doing something like a test with your pencil on your paper to test to see if it's a function. You remember what that's called? The vertical line test. Y'all never did that? Okay, so what the vertical line test does is it says you can take any vertical line and you can go across the graph. And if it ever hits that graph more than one time, then it's not a function. In other words, like this one, twice, not a function. Because that's telling me I've got two outputs for one input. But here, there's nowhere that I could draw a line where it's ever going to hit more than one time, so it is a function.
Our algebra 1 teacher was.
Because it only has one y.
Because each x only has one y that goes with it. You're exactly right.
I think we learned
I think you did, you probably just don't remember.
that. I think we did learn that.
Okay.
Nervous, Lopez?
All right, let's go back to that equation that I first gave you, which was 2x plus 5. And because I initially told you that it was f of x, then you can know that it is a function. And it's going to look something like this when graphed, right? All lines, by the way, are functions, unless they're vertical lines. Okay? So now my question to you is, think about this for a minute, and think about whenever I showed you that T-chart, what happens with inverses. How do you think I can find an equation for the inverse of that line?
Make the
What was
opposite.
the opposite?
Make what the opposite?
Everything.
What happened on our T-chart?
Flip it over the negative axis.
What happened on the t-chart? Look at the t-chart. What else?
It went from multiplying by 2 to dividing
Can
by
you see that they literally switched places? The x and the y? So in the equation here, to find the equation of the inverse, let me do this in another color so you can see. You can do the same thing. Switch x and y. Okay, so x equals 2y plus 5. Now I can solve for my new y. How do you solve that for y? I just want to get y by itself. I don't want a specific value.
Subtract 5.
Subtract 5. X minus 5 equals 2y. Now
And
what?
then divide by 2. Wow.
So you can leave it like this. Because I'm fixing to graph it and show you what it looks like on the graph, I'm going to do 1/2 x minus 5/2 equals y. These are inverses now. This equation and this equation are inverses of one another. Okay? Does that make sense? Yes, no, maybe so?
Yeah.
So now whenever I graph it,
Miss McGee, speaking of fractions, for that one, you put a y under the x, and you like, that one.
a y under the
I mean,
x.
a 1 under the x, my bad. A 1 under the x, since it's on top, there's like nothing on the bottom.
You know, I just wanted you to see that that was the slope. But you could if you wanted to.
So that's how you solve it.
So that's how you solve it. I'm going to show you the graph with another one so you really see. Does that make sense? Let's look at it. Let's look at one that's a little bit harder on a graph. Let's say, actually, let's do one more of these. Let's do one more of these. Let's find the inverse of 2x squared minus 6. You find the inverse. Find the equation of the inverse right now. What did you do first?
Subtract that, or add that 6.
Add that 6. I'm going to change this to a y. And then I'm going to switch them around exactly. I'm going to say x equals 2y squared minus 6. Now, Ben, you're absolutely correct. Add that 6 to both sides. Now what?
Can you put it in parentheses and remove the
Divide 2.
Yeah.
Anna says divide 2.
It's still just now do you move the square?
Yes, Ben. Now I would do. Right now we're just going to leave it just like this. Okay? Function notation, which is f of x. Okay? To indicate inverse, this is what we do. This is not f to the negative 1 of x. This is the inverse of f of x is how we read it. So if you ever see that, you know that's indicating that it's whatever f of x is, this is the inverse of it. Okay, that little negative 1 exponent on the f tells us that they're inverses. It's just notation. Yes, no, maybe so? Ben, you want to open that door, please? Does that make sense? Do I need to do another one? Y'all okay?
Do another one.
Do another one. Okay. Let's say I had f of x equals 1/2 x to the 3rd minus 4. Find the inverse. I know some of you are still working. I'm just going to kind of take it slow. I'm going to switch my x and my y here. What'd you do first? Add the 4. Now what? Or multiply by the reciprocal. I'm going to multiply by 2. Don't make this harder than it is. Leave it just like that. I'm not asking you to expand it out. I'm not asking you to distribute. I'm simply asking you to find the inverse equation.
If you divide by 1/2, would it look different?
Well, you don't ever want to leave. That's a complex fraction. You don't ever want to leave a fraction in a fraction.
Wait, why do we,
Well, there's still something else hooked there. What is it? How do I get rid of that? Cube root it. And look, don't make life harder than it is. Leave it here. Leave it as cube root of 2 times x plus 4 equals, I'm going to change this back in function notation from y. Does that make sense? You can, yeah, you can leave it like that. That's fine. So if you multiplied everything by 2, you had 2x plus 8. The cube root of that. That's fine. You just can't break it down any further than that. Even though 8's a perfect cube, because it goes back to those distribute and FOIL properties kind of thing, you can't split up the...
well, 2, what did you multiply? Or what did you do?
Yeah, to get rid of this 1/2 right here, I multiply both sides by 2 over 1. The 2's cancel, the 2 and 1/2 cancel out.
So you add the 2 once you get that 2? Or you
Multiply it.
Oh, so you're not dividing 1/2 by 4?
No, you don't want to do that. You would, if you divided 4 by 1/2, you multiply by the reciprocal there to do that. So it will be 8. 4 times 1/2 is 2, but 4 divided by 1/2 is 8. Other questions? Yes. Let's do... Oh, my mic is going to look on your homework. F of x equals 7x to the 5th minus 7. Try this one. I'm going to switch my x and y around. What'd you do first? Add 7. Now what? Divide by 7. What if that had been a 1/7 in front? Multiply by the reciprocal, right? All right, so I got x plus 7 over 7. If you want to split that up 1/7 plus 1, you can. I'm going to leave it like that for right now.
Wait, so when you're doing the fraction like that, can you just
Leave
do
it?
2 7 and put it at 1?
Yes, but you would have to do it. That's what I just said. You could do 1/7 x plus 1. You just have to take it to both. That's the problem. You can't just do it to one, not the other.
I just put 1.
Where did the 7 on the Wi-Fi go?
Where are the 7 what?
On the Wi-Fi go?
I divided both sides by 7. So now the inverse of f of x is the 5th root of x plus 7 over 7.
Why did you put all that extra stuff
What extra stuff?
after the -1?
That just changed, I just changed notation. That just indicates that I started out by defining f of x, so now the inverse of f of x is that. It just tells me that it goes with the first one, yes. That's what the -1 means.
Can we agree that's the one?
Ye-
So theoretically,
Yes,
if we had
yes.
a test on this, we don't have to simplify it all the way. We can just kind of leave it.
Simplify it all the way how?
Like,
No, you don't have to work out completely. I just want you to go solve it in the right order. Remember when we're solving, we're going SABMAP. Okay? All right. So that's kind of, I won't say an intro to this lesson, but
Go ahead and say it again.
This is easier than one.
we're going to use the functions to do something, the inverse functions, okay? Let me first show you graphically what these inverse functions look like. Because just because you start out with with a function being a function passes that vertical line test, Doesn't mean its inverse is a function. So I want you to look at this with me for a minute. We've graphed a lot of these. That's a what?
Parabola.
It's a pretty jacked up parabola, but it's a parabola nonetheless. Is it a function?
No. Yes. Yes.
Yes, why?
Because it only interpolates.
Every x you have on there only has one y that goes with it. If you put a vertical line there, it only passes every one time. Now think about this. I told you, and we've talked about, that the inverses switch the x and y, right? Let me draw this a little more symmetrically so you can really see it. So if this is my function, let me just say that this is 0, 0. This is 1, 1. And this is 2, 4. Okay? If the inverses switch the x and y's, that means my inverse is going to consist of the points. And of course, this is symmetrical, so this is negative 1, 1, and this is negative 2, 4. My inverse points are going to be 0, 0, 1, 1, 1, 2, 3, 4, 2, 1, negative 1, and 4, negative 2. Look what's happened to my parabola. What's it done?
Ooh, it flipped over.
It flipped over. Literally, if you can picture it in your mind, what was once the x-axis became now the y-axis. The x and the y switched places. What?
Why you have to make it so complicated?
I made it complicated?
Yeah, that's a bunch of numbers.
Because I wanted you to see the coordinates. I want you to see the coordinates changing places. If this is 2, 4, then the inverse point of that is 4, 2.
You know what you can do? First, you grab the first one, color it in dark, and put a sheet of paper over it, and trace it, and then turn the sheet of paper.
How's that? Oh, I see it.
You're actually not wrong. You could. You could do a rotation. Yeah, what?
Oh, we learned that in her class.
Ask me, Tyshawn, what'd you say?
Wow.
No, I got it.
Okay.
I was wondering why that 4-2 was at the top, but I see that it's symmetrical. So that means it's both.
Right. So, and whatever these points are, the x and the y are flipped around. So now I ask you, you told me that the blue was a function, right? Right, David? What you looking at over there, buddy?
It's fine, take it.
I'm going to put passes VLT. VLT means vertical line test, right? So now I ask you, what about the green?
Green is not working.
The green does not work. The green is not a function. Why?
Put the red thing.
Look.
Miss McGee, hold up. Hold the phone.
Hold the
So
phone.
you're switching all the X and the Y's. When you switch at what the thing you go by.
Actually, you're absolutely right. That's what I was getting ready to tell you.
Like that.
If you only have a picture of the graph, and you will have one of these on your test, fails VLT. If you think about it, let's say I only had the blue graph to look at. So I only have this. Now Banks can switch that around in his head, trace it on a piece of paper and rotate it around. But let's say I just asked you to look at that one graph and say, is it a function?
Yeah.
Yes, why?
Because it only touches one.
Only touches once. What if I asked you, without graphing, if its inverse was a function? Ben, I think this is what you were trying to get at.
Yeah.
What could you do? How? Why?
Because it's going to flip. The X and Y.
What's flipped? Okay, yes, but what kind of test could you, if you use the vertical line test to test, you could change it, right? If you're just rotating it that way, you can just make it a horizontal line. So vertical line test checks for a function. The horizontal line test checks the inverse for a function.
Well, when is that ever going to When is the horizontal?
Like, when will they both be functions?
Yeah, like.
I'm going to show you. Those are special functions, and I'm glad you brought that up, Tashawn.
I mean,
No. If it passes both, that is a very special kind of function that we call 1 to 1.
1 to 1.
1 to 1. Linear functions are 1 to 1 except for vertical lines because they pass it no matter what.
Oh, so
Okay.
the line-
Cubic functions, those cubics that look like that, even if you switch them around,
Yeah.
this, I'm going to go back, or this are both functions. Either way, they're functions, so it's 1 to 1. I'll go back a second and let you copy it now.
That's a.
What, intuitive?
Yeah, that's hard. That is hard.
Here's where we apply something that we already learned. You'll see why we learned it. To verify inverses. So let's take these two things. Let's take two things that we know are inverses. In fact, let's use that very simple linear function that we did in the beginning. It was it 2x plus 5?
Yeah.
I'm going to rename the inverse. I'm going to call it g of x. And we got x minus 5 over 2. Or 1/2 x plus 5 over 2, right? Either or works. Here's what happens when we verify inverses. In order to verify inverses, you have to think about this like a proof from geometry, okay? We have to show two things in order to prove that they're inverses. We must show that f of g of x, here's that composition again, will simplify down to only x, and so you have to show two things. G of f of x will also simplify down to only x. Okay? So it's got to go forwards and backwards. So I'm telling you what to do, and I'm telling you what the answer is going to be. Your job is the middle work, which basically means canceling things out in the right order. Okay? Proving that they're inverses. So let's work through this one. Remember, showing both, you can't just show one. So let's do f of g of x first. What is g of x? X minus 5 over 2. Is this where y'all said you were struggling with the fractions and the composition?
Yeah.
Okay. When I plug this in to f, right, I get 2. It's not x anymore. It's x minus 5 over 2 plus 5. Now I need to simplify. And when I simplify, remember, I'm going order of operations. We solved the first half of this lesson, SADMAP. Now we're simplifying, which is PEMDAS. Yes? Okay. From the original equation, 2, x changes to this, and then 5. Composition. This is the composition. Like if you could literally remove that x that's hooked to that 2 and replace it with what's in parentheses at the f there. Do you see what I'm talking about? If I could pull this out, because it's telling me, remember the example we did where we said like f of cat. It doesn't matter what's in parentheses, whatever's in parentheses replaces the x. So this replaces the x here. So it's 2, this, plus 5.
Just that, replace that.
It's gonna, yes, and that's the point. It's gonna reduce back down. All right, so listen, when you have a fraction like this, I can put this over 1 and I can multiply. Or I can be a little bit more intuitive about it and know that if I'm multiplying top and bottom, and I have 1 in the top and 1 in the bottom, what happens? Look at that 2. What happens with that 2? It cancels, right? Does everybody agree with that? So I have now x minus 5, and you have to show me this all step by step, okay? Because you know these cancel. I'm telling you it's gonna equal x when you're done, okay? So please do not get to this point and go and plug it in and then go. I want to see each and every step it takes you to get there along the way. Okay? That's your job, is to justify.
So this will go to test like that?
It'll say verify that the following are inverses of one another. And I'll give you an F and I'll give you a G. But I'm not done. Right?
Wait,
What did I tell you? How'd I what?
How'd you get 8?
That's a 5 I crossed out.
Oh, yeah. I was so
They're going to equal X every single time.
Unless it's wrong, right?
I will not give you wrong ones like that. All right. Let's go the other way with it. G of F of X. So it's now G of 2x plus 5. So take G, and in place of the X, I'm putting 2x plus 5, right? So in the fraction, I've got 2x plus 5. There's the X part. What's left? Minus 5. Everybody goes over 2. What cancels first?
5.
The 5s, right? Fractions group things together. Grouping is the same as parentheses. So I do that first. Now what? When it's in the top and the bottom like that, and I'm multiplying, I just cancel them out. This verifies. This verifies because I have shown that when I plug one into the other and then I go backwards on it, they both equal X.
And what are we doing? I mean, like, what is this?
We're verifying inverses. Think about this like whenever you did proofs in geometry and you had to prove, you knew what it was, you knew it worked, but you had to prove it step by step, same kind of thing. So remember, in order to verify, you're showing two things. You're showing that f of g of x will simplify down to x, and g of f of x will simplify down to x. So try this and then we'll do it together.
Oh, wait.
Oh, I forgot to record that
'Cause it makes
explanation.
it 1, because it makes other things.
Correct. You're right. Absolutely, because when you raise a power to a power, you multiply, and 2 times a half is 1. So- So remember, you're going, this one, you have to go in order of operations. So we're going PEMDAS this time. And that's going to be the hardest thing for you to remember is which order to go in. So remember, solving is SADMAP, simplifying is PEMDAS. Okay? So I get 5 times, oh, this is 1/2. All right, I got x plus 2 over 5 to the 1/2. Squared minus 2. Okay? Watch. Ben, I see your phone beside you.
Stupid North Carolina number was calling me again.
Answer it.
Twice a day.
No. Ben, answer this.
Oh,
What do we do first?
Subtract that 2. Oh, man.
We just talked about this and you said you understood. Come on now, you can do it.
Distribute the
I can't do anything in the parentheses, so I'm up to exponents now. 2 times a half is 1, and an exponent of 1 is understood, so I can cancel those out. Okay?
So you'll be going out of order if you cancel the 5 out?
Yes. And remember, that's what I'm checking. That's what I'm looking for. Okay? Yes, you have to go in order of operations. So listen, because that's a good question. This is where you will lose points on your test, so I need you to understand. If you canceled the 5s out first, that is not correct, okay? The whole point in this is that you're going in the right order. So parentheses first. I can't do anything inside parentheses. Exponents come next. So is there anything I can do with exponents? Well, yeah, there is. Okay, so I have to do exponents first. Now I can move on to multiplication division, which is the 5s. Okay? So I got 5 times x plus 2 over 5 minus 2. Well, now I can take care of those 5s. It works. Awesome. It works forwards, but that's not enough. I also have to show it backwards too. Because just like a proof, I have to show beyond any shadow of a doubt that, well, this one's not like a geometric proof. We're not justifying with properties and theorems and laws, and we're just, all right, so f of x is 5x squared minus 2. Okay. So in the G, I am replacing the x with 5x squared minus 2. So I get 5x squared minus 2 plus 2 over 5. Now, you might want to do the exponent first here, but don't, because parentheses come first. Is there anything I can do within the parentheses before I move on to the exponents? Cross the 2's out, absolutely. So now, still working in my parentheses, what cancels? The 5's. So this is all about the order. Now I can do the exponents because now I have simplified inside the parentheses as much as I can.
Wait, so for each different ones be different. So one's please keep my dear and son,
So simplify is please excuse my dear Aunt Sally. Solve is sad math. What?
Oh, that's what PIMDOS means.
Yes, so look, simplify, which is verify, is PIMDOS. Solve
Vision. Addition. Subtraction.